Hello and welcome to our webinar today. My name is Christy Amobi and I work in the product division at Xray. I'm also joined today by Amanda Tulk, who's the Chief Science Officer for Xray. And we are delighted to welcome Dr. Dominika Oborska from the Cancer Centre London. She will be presenting a medical physicist point of view on superficial and orthovoltage systems as part of a comprehensive radiotherapy offering. Dr. Oborska, as I mentioned, is a medical physicist from the Cancer Centre of London and has been using this type of equipment for some time, and she's going to go over a lot of topics that are interesting from a medical physicist point of view. Pardon me. So with that, I'd like to go ahead and turn it over to Dr. Oborska. Give me just a moment to set that up. Thank you again for your attention and participation today.
Good afternoon. I'm going to present, this physics approach in terms of X-ray radiotherapy. And sorry unfortunately for these sounds at the back. I was going to present this material in the conference room, but unfortunately technology was working against us, and I am in my office. But I will try my best to provide what I wish to present to you, and hopefully I can a little bit also attract subject around of X-ray therapy. And historically, the X-ray therapy was one of the first type of treatment for cancer diseases used, in clinical practice. Afterward, I think that it was like this technology was going a little bit to the shade, because LINAC technology and other modern technology, how it was called, they a little bit, like I said, they maybe not overlap, but definitely they push away. But afterward, it appeared that still this technology, and I think that we can agree that during development, all technologies, they don't have to be completely withdrawn. Very often they fulfill some specific, fields, professional fields, or some cases which can be treated with X-ray therapy, and even it is better if they can be treated with X-ray therapy. Okay, if we are going ahead, we have got exactly this system. We've had 200, which is installed in our cancer center, and it is a relatively new system installed about 2 years ago. And it is also ceiling mounted system, and mainly we treat here benign diseases and skin cancers and scalps, and definitely it is treated as a superficial treatment. And our system has also this has two modalities, so 2 platforms really. Concerto, it is for clinical uses, and Physica, which is used for engineers and physicists for quality assurance. We have not our system is not integrated with management system like Mosaic or ARIA, but I know that it is possible to integrate, this system with management system in radiotherapy. And like I said, it is system which can cooperate also with current requirements in terms how patients they should be managed, how they should be registered, and how this treatment they should be recorded. We can recognize really in KV radiotherapy, we can recognize 2 areas, superficial and orthovoltage. It depends on energy, and like you can see in the table, it depends what authority body or what kind of professional body, gave recommendations. It is split a little bit around of 100 kV below and 100 kV above, depends who who recommended specific splitting these two areas. It means that lower energies, they are recommended to use for superficial treatment like skin, and orthovoltage treatment can be used for deeper radiotherapy, but no deeper than 5 centimeters. And it is definitely, split by energy. Why X-ray therapy fulfills specific area in cancer and no cancer lesions treatment, because it is low energy and has specific, spectrum of this energy has specific also interaction with matter. It means that we can say about specific dominated effects because of energy of radiation. For KV treatment, we have got definitely, maybe not dominated, but significant part of these interactions which can be assigned to photoelectric effect. And without deep analyzing what does mean photoelectric effect, I have put this slide here just only to highlight one aspect. This aspect is that this effect depends on energy, but also depends on atomic number of matter, which is like an attenuator. It means that this effect can be boosted if we have got and we can provide interactions with tissues with a higher atomic number. If you look very carefully, you can find that bone has 60% higher atomic number than soft tissue. It means that if we have got this photoelectric effect, it means that this effect will come and will appear when we'll meet bone anatomy. If we go ahead, also the second really in this energy, second effect which we can observe as a interaction with matter is Compton interaction. And what is the most important here? That okay, it depends on energy, but is independent on atomic number of attenuator. If we look at the next slide, we can see how atomic number and how matter and attenuator can change this statistic for specific effects depending on what kind of material we have got, to interact. It is a graph for copper and water, and we can see that for water, Compton effect is wider, and photoelectric effect is moved to lower energy. If we treat, that copper as a representative for bone, we can see that this photoelectric effect is moving, ahead with energy, and this interaction, can happen, more often. Now we have to go to next aspect. Fact that we have got interactions of radiation depending on what energy is interacting with attenuator, with tissue. We have to remember about effects. We want to meet specific effects. It means how much energy is lost on the track of this radiation, and really we are interested in collisions, in interactions. It means that we treat this part of energy which is lost on real interactions, because it is exactly what we are expecting from radiation. And and parameter which describes which describes loss of this energy and at some specific, track length is called linear energy transfer, and is expressed by exactly how much portion of energy which been deposit in interactions been lost at some specific unit of length. Why this parameter is important? Because such physical parameter can be transferred to information about radiobiological effects. And we have got, and now we can try to assign this physics to radiobiology. It means that we can say how physics affects radiobiology or biology to get, treatment effect. Biological parameter which describes interaction and with radiation as an effect of surviving or effect of killing cells is expressed by relative biological effectiveness, which means that we compare how specific energy interacts and works with biology in relation to some reference energies. And to express relative biological effectiveness, we compare these how specific energies they work for this parameter. We compare to 250 kilovolt energy all to gamma X-ray. It means cobalt unit, cobalt energy. And how it works. If we remember what does mean linear energy transfer and relative biological effectiveness, we can see how physics can be assigned to biology in terms of interaction with radiation. And it is, if we know that this comparison is is expressed as a ratio between how many cells they can survive by exposure by the same dose with energy for cobalt unit or for 250 kVp, and this ratio is expressed by dividing value of survived cells for reference energies to energies which are represented by site locally, which we want to investigate how this parameter can behave. We can see that higher linear energy transmission gives us higher effect of survival of cells. If we look at this table, I think that it can be more visible. If we try to express RBE in relation to cobalt radiation, and it is a reference energy, we can see that X-rays, they have got RBE by 10–15% higher. If we remember that it is ratio between reference and local energy, or this energy which is investigated, it means that really more cells they can survive for the same dose when we use cobalt unit. It means higher energy. But we are more interested in killing cells. I have got another example which is expressed in relation to 250 kVp. It means that it is diagnostic X-ray. If diagnostic X-ray is 1, immediately we can see that high photon energies and gamma energies, they can provide like a better survival and worse killing effect. Going ahead, we have got another parameter which we take into account when we think about effectiveness of radiotherapy. It is also oxygenation level in terms of cells. We can see that if we have got higher lead, at this moment oxygenation effect is going down. It means that this oxygenation effect is less, the significance of this effect comes down, or strength of this oxygenation effect goes down with a higher LET. What also, can be transferred to biological information, how this energy can effectively kill cells. It is summary. It is what been presented really in previous slides. But as a summary, we can say that higher lead, it means that higher deposition of energy per distance unit. At this moment, effectiveness of killing cells is also higher. Plus, we have got also this effect that oxygenation effect is going down. Clinical practice. We treat mainly we treat here Dupuytren's disease and colloids. Also, after surgery, we also treat scars, to protect against this pathological overgrowing. But for this kind of surface treatment, it is very beneficial because 100% of dose is at the skin for this energy. Also, benefit of this solution is that we can reach very difficult places to be treated. Can you imagine that, for example, that eye treatment and some skin treatment around of eye, nose, ear, how can be difficult to try to provide this treatment on accelerator? Obvious situation that at this moment we should maybe think about electrons or some boluses, some additional stuff, but and accessories, but it is quite difficult to treat these places using linear accelerator. And X-ray units, they give a very big technical like a flexibility, and source of this radiation can be rotated almost in any direction. Also sealing, when it is sealing system at this moment, we can reach and rotate around of patient can sit, can take comfortable position, and definitely it is more flexible. If we have got also older people who have got problem with management of their movement and some disability, this system definitely supports this kind of situations. I have found some presentation. They try to compare this a kilovoltage clinical application, but with electrons for some specific case, and they found, of course, that the advantages of electrons. But I think that we can still, speak about, low energy photons, because firstly, treatment is very simple. Like I said, reaching this place, approaching this place with this construction of the system is very easy. We can treat very small lesions, and because the smallest our applicator is 1.5 centimeter. And like I said, if we wanted to treat skin, you can see that for electrons we have to use bolus. For this solution, this bolus is not needed. We have got also some example for our case, because we also treated Peyronie disease. Looking at energy and how this, if we prescribe those at mid-plan, we can see how energy at the entrance can behave. And already from 160 kV, for 3 cases, you can see that those at the entrance is maximum 4% higher than at mid-plan. It means that it is quite acceptable. And again, reaching this place using this solution is simpler. Next part of my presentation is also saying about how it is easy to introduce this system to clinical practice. We have just, about 1.5 to 2 years ago, we have, almost 2 years ago, we are introducing new system after replacement to the practice. Everything started, of course, that after installation, which I don't remember, but I think that it was lasting 1.5 weeks. Engineers, they were ready to do acceptance test and do handover report and to provide specific, checks and verification. Really, we have checked, they've been checked, everything will been checked in relation to electrical wiring, generator, everything, and this kind of stuff. All electrical, parameters, and all, if cooler was working, emergency buttons, if they working. Warning lights, because it is safety aspect related checks. Really, it was like a table and tick boxing, following quite big document and verification if system is working safely in terms of installation, in terms of electrical stuff, as well as software and all warning lights and so on. Also, we have checked if our filters and applicators, they've been working, they've been recognized, they've been named properly, and so on, that we had to, that we could not have any contradicted information. And this identification of applicators is simple, straightforward, just to simplify setups. And also we have got, you know, all these manuals, all the documentation, and you can see also on this slide that the center of focal spot position been checked with a special collimator which been brought by engineers. It is a pity that client can't have, but I can imagine that it is very proper, specific, you know, tool to verify. And looking also at construction, it would be rather impossible that this center of the beam could run away somewhere or be shifted till this time that definitely this head is not hit somewhere. Going ahead, next part was done by external providers, and they provided critical examination. It was lasting 1 day, and on the slide you can see listed set of parameters which have been checked, from environmental measurements if our room is safe, and this like an environmental investigation to check how leaking of those, you know, is going through the walls, to identify local rules. It was really to identify local rules and potential, you know, risk and so on. All safety aspects, they've been checked, any switches, emergency stuff. They check also leaking of X-ray tube. It means that if this cover of X-ray tube is also effectively protective. They check energies and then protective equipment labeling, and they confirm that definitely system which is on site is exactly this one which been documented and been verified by acceptance test. And when we got the final documents, and we could confirm that we can start our verification, we have started commissioning, and we have started from identification energies, measuring, you know, HVL. It is how energy is represented or expressed. It is by half half value layer. It means that this thickness of material, which is and mainly is used aluminium and copper, and this thickness of this material, which reduces those at the exit or at the measurement point by half. It is information really about how energy transmits through this material, and it is expression of energy. It is this setup required specific, you know, this measurement required specific setups, and the most important was that we had to simulate small field to represent, you know, how it is possible, how much it is possible the primary beam with reducing a scatter. Also, distance between attenuator and source should be at least 50 centimeters to avoid, you know, any scatter stuff, and also chamber had to be at some specific distance. And unfortunately, because very often these KV rooms, they are relatively small, it is quite crucial to check if definitely chamber is far away from walls, ceiling, or no ceiling, from walls, floor, and any constructions which can be can be sources of any scatter radiation. And it is our table, and we have measured HVL for all energies which we have got implemented here. Really 30 kV we don't use clinically, we use from 60 till 160 kV, but because it was commissioning, we made the decision to do everything from the scratch point. Having energy, which is quite important, we could start to do intercomparison. It means that we could prepare our chambers also for measurements, those measurements which must be done afterward also regularly to check if output for this system is stable and constant. And also we had to also identify absolutely this dose at the exit of applicator to calculate time, exposure time when dose is prescribed to the patient. To do this, we had to use our secondary standard set to compare with our field electrometer and chamber, and it is exactly this setup which we use for this intercomparison. Energy is needed because calibration factors which are expressed and provided for secondary standard by NPL, they are dependent on energy, and this energy is expressed by HVLs. It is a reason that we started, measurements from identification energies for intercomparison, that we could go ahead afterward with rest of measurements. It is graph which we have got for secondary standard, and we can afterward approximate by trend line, and again use for this cross calibration for our field chamber. Part of this intercomparison was also establishing, specific calibration parameters which have been expressed by polarization and recombination effect. Fortunately for this energy, they are quite low, and that they don't affect, significantly. They are not very sensitive in relation to energy. It means that they don't affect, such much those measurements. Going ahead, it is result of our cross calibration. You can see the final table, which is expressed again like by kV energy, HVL, for aluminum and cuprum, and express a calibration factor in air for our two chambers, which we use in clinical practice. Afterward, like I said, we have got different applicator sizes, and we have tried to cope with the smallest field sizes, because always measurement outputs and any parameters for the smallest field sizes is the most difficult. It is one of the proposed setup. Second setup was, and we try to we use parallel electron chamber, because this measurement is really relative. It means that we had to compare results for our reference applicator size to the applicator to this small one, to take this relative output factor. It means that related to field size. We have used also another setup. It means that we have put, standard thimble chamber far away from the system, and we try to expose with high dose to get, at least readings which been, significantly higher than sensitivity of the measurement system. And by getting, this big distance, we try to magnify field size and make this a field size which been projecting on the chamber big enough that size of the chamber would not affect, final measurements. And the last solution was that we use this thimble chamber in perpendicular direction. It means that we have decrease size of this chamber to cross section, just to compare. And finally it appeared that all these sets, they gave us similar results in acceptable, I would say, level of differences. To establish also, chamber position and so on, it is maybe not the original, setup, but I would like to show gaphromic film. That gaphromic film used, they can support setup, and also we try to measure, output, relative output factors, but it was not such easy like we have found finally for chambers. But I'm showing also this picture to show that gaphromic film can be very useful in relation how to set chamber in relation to the smallest applicators. It means that we can find projection on the gaphromic film and confirm that this thimble chamber is centrally positioned in relation to the field, to the applicator. And you can see here that we have put our results to table and compare. We have done for the smallest set of applicators, we have done 3 sets of measurements and with independent groups just to confirm for the most critical setups that our results they can meet tolerances, and that we can confirm that definitely these outputs they've been measured correctly. And to fulfill information, we have taken backscatter factors and mean mass energy absorption coefficients from publications. It is recommended by code of practice, and we could use easily. The only thing that we have also compare APM and IPM tables, and we didn't find significant differences, and we have implemented finally APM. PDDs for this system we didn't measure. It is data which I have found and on site here, and it was measured for the old system, but also PDDs that are given by publications. They can be measured, especially if we have got orthovoltage system and we want to prescribe those to the midpoint of treated area. Going ahead, we, as a one-off part of our commissioning, we try to also see how profiles they behave, because as it is known, for X-ray units and for this solution, that source of radiation is X-ray tube, we have got a Hill effect. It means that partially radiation from anode side can interact with anode material. It means that from that side, this intensity can be lower. I would like to show you, it is the most visible for diagnostic radiology, but it can be compensated by specific choice of anode angle and also focal spot size. If you could see here, you can see that for big focal spot size, we can get quite good coverage of the field, what we are interested in here. It means that in radiotherapy, we are interested in good coverage of radiation field. But the most important in this, that also angle of this anode is chosen in that way that significant part or part of radiation which goes from anode side is not interacting with anode material in that way that this coverage can be decreased, and we can see this like a wedge effect. If you look very carefully at this moment, we can say that B solution is representing X-ray tube for X therapy. And it is again next slide which shows how this Hill effect can work. This example is for radiology and is the most visible in mammography. But if we go to our results, how we measure when we measure our profiles, Firstly, I have confirmed what is an anode angle. Anode angle for diagnostic is about 20, 16 degrees, 15, something like that. And focal spot size is about 1 millimeter, 2 millimeters, 3 millimeters max. Even for mammography is 0.1 millimeter. If we go ahead, we have measured our profile for 60 kV, and you can see this heel effect is not such strong, but is visible. But we can say that we are still happy with this coverage of field, but of course that it will be significantly better for 160 kV because of higher transmission. And we just, checked how this coverage, and if we can say that we have got uniform profiles. And really, it is everything what we have done in terms of measurement and commissioning. Afterward, when we had, output, relative output factors and output factors and outputs for reference applicators, we could create tables, timetables for patients' treatment, and purely and directly, like I said, because we don't treat patients at the depth, and those is prescribed at the surface. It means that we could create one set of tables for each energy, for each applicator. We have got purely and straightforward time which can be given for specific dose. And afterward, we had to prepare. We have also prepared baselines for routine QA, and we have started to measure regularly specific parameters which are in line with valid code of practice. And monthly we check output really only for reference applicator. 6 monthly we check also some safety aspects, applicators, factors, linearity. It means that if system behaves linear in terms of time and deliver those. We check still like a flatness, but we don't use a profiler. We don't check profiles. We check with chamber at specific positions, and because we have collected these baselines for chamber reading, it means that it is enough that we will take, we would take, the biggest applicator and measure, at sensible points from the central axis, and to confirm that still measure values out of axis data, they stable, and they agreed with our baselines. And annually we check energy for the system, and it is really, in terms of introducing this system to clinical practice, it is quite easy and quite quick process. Afterward, of course, that after commissioning, we had external audit, and the independent group of physicists, they came here and they checked with their own protocol our parameters. All of them, they agreed in the range of acceptable tolerances and expected values. And when we got this final audit result, we could, and we have introduced the tables review, of course, that, and validated timetables. The system, so we started to use this system in clinical practice. And now I would like to say thank you. And the only thing which I would like to highlight, from my background, I have found that that this system is definitely something what we should think that fulfills specific treatment. It is not something what is to cover. It is not something what should push other type of techniques, but it is something what can be treated as a part of composite treatment. For example, for orthopedy, for surgery, can even delay some straightforward solutions, especially orthopedical stuff, and also it worked very well as a pain killing. works also very well for palliative patients, especially with metastasis. And if it is spine, definitely, orthovoltage could be used, especially that gives, this possibility that patient can be approached very easily, can be treated, I think that is superior in terms of treatment scheme, especially around of places where this access is again very difficult, or we have to treat very small lesions. We rather should think about this system as a system which has some delegation in terms of radiotherapy treatment for benign diseases and for cancer diseases. Thank you very much for your attention, and please send questions. I hope to reply. Thank you.
Thank you so much, Dr. Oborska. We do have a few questions coming in. I just would like to remind everyone, all of the attendees, that you can post questions using the questions function of the GoToWebinar control panel. The first question coming in is around the number of patients. What number of patients are you treating every month with this type of technology?
And really answer, is now the difficult because COVID, changed a lot of things. But I would say that last statistic, which I remember from previous year, it was 300 patients a year.
Okay.
300 patients a year.
Thank you. Yes, you're right. COVID has definitely changed the landscape quite a bit.
Yeah.
Next question. How long does your routine QA take?
It is very, very easy and very, very quick. Even annual test we can do monthly, because we have optimized also our protocol in terms of code of practice. I am very happy to share this measurement protocol, and it means that monthly check, because it is only one output really. For reference applicator, it can take like a maximum 1 hour with full setup. If we do 6 monthly tests, it is half day with HVL. I think that half day and something, a little bit.
Okay, thank you. Next question. What method did you use for measuring the profiles?
We have used matrix, really matrix, and which we have got also for standard PSQA, the patient-specific QA. We have used matrix to check profiles, because we were interested in Hill effect and how this coverage is for this profile, and how this profile is symmetrical. And it was also answering if we can introduce this method of using chamber, and how we are safe with this like a 4 points measurement to check, relatively if these profiles are still the same, and then just to ensure us.
Okay, thank you. Next question. How long would you say it takes to commission each clinical energy?
And totally our commissioning, because we didn't do per energy, we did this, comprehensively, really. And I think that, if everything goes well, maximum 2 weeks.
Okay, thank you.
But I think that with releasing data and something like that and so on, yeah.
Okay, thank you. That was our final question, Dr. Oborska. Again, on behalf of Xray and all the attendees, I'd just like to thank you again for this comprehensive overview. This was very helpful and educational. For those of you on the line, just a quick reminder that you will be receiving a recording of this presentation from Xray, and you're welcome to share that with any colleagues who weren't able to attend the session today. Again, thank you so much for your attention, and we really appreciate your time. Have a great rest of your day. Thank you so much.
Thank you very much.